Hello, people. This is my third attempt at filming this, so I'm very tired of doing it. This is going to be quick. These are just all of our formulas for taking an antiderivative. Your book also has a good list of all of them, but I thought I would write out the ones that we're going to focus on first. I gave you a similar list last year, but I tweaked it a little bit to make it better. So to just start with, we've got the reverse power rule. So remember when we're taking antiderivatives, this is a different way of looking at an integral. Yesterday and the day before, you had integrals that had limits of integration. That meant we were looking for area under a curve. So if the piece was straight, we found the area under that. If it were a circle, and then if not, we used a Riemann sum. Now we're getting rid of those limits of integration, and what we're looking at is called an indefinite integral. It doesn't have limits. So now we are calling it also an antiderivative. So when we're given one of these problems with these integrals or antiderivatives, we're trying to figure out what came before. The derivative of what gets us to the thing that they gave us. Sorry. So the very most basic antiderivative that we have is our reverse power rule. So instead of taking the derivative of, let's say, x to the fifth and getting 5x to the fourth, I'm now taking the antiderivative and saying that instead of adding one from instead of taking the power, subtracting one and putting that original power in front, now I need to add one to the power and divide by that new coefficient or that new power. Oh, I'm tongue-tied because I don't feel like doing this anymore. Love you guys though, but third time I want to throw my computer through a window. So anyway, we've got our reverse power rule. After this, I want you to get on and watch the second video, which did work out the first time. And it's me going over all of the problems that we would do in class if we were doing these notes together. So I think the practical application, actually doing the problems, is better for you. But I wanted to just mention a couple of things. So we've got reverse power rule. We've also got the integral of a constant. And remember that little dx is just a notation. It's telling us we're in with taking the integral with respect to x. So the integral of a constant is just the constant times an x. Think about that. What's the antiderivative, or what's the derivative of 5x? 5. What's the derivative of 10x? 10. So the antiderivative of 10 is 10x, 5 is 5x. We have the plus c on here because think about any of these. If I were to take the derivative of kx, I'd get k. But what if I had the derivative of kx plus 6? I'd still get k. So I can add or subtract any number onto the end of any of these, and when I take a derivative, still it would go away because the derivative would be 0. So that's why I have a plus c on the end of all of them. We go over to our trig. Oops. And we have our most basic, what's the derivative of sine? Cosine. So our most basic ones here. The derivative of sine is cosine, so the antiderivative of cosine is sine. The difference between now, the antiderivative of sine is not positive cosine. The antiderivative of sine is negative cosine because the derivative of cosine is negative sine. So this is a lot to train our brains now to go backwards quickly, but here we are. So hopefully you were decent at it last year and you'll be even better this year. In addition to sine and cosine, we also know the antiderivatives of 4 more trig functions. We know the antiderivative of secant tangent because the derivative of secant is secant tangent. We know the antiderivative of cosecant cotangent because the derivative of cosecant is cosecant cotangent. We just have to be careful with our negatives. What's with this AU, you ask? Well, if I have anything here other than x, if I have a constant times x, when I was taking a derivative, I would multiply by that constant. Now I'm taking an antiderivative, so I have to divide by that constant. It's like undoing chain rule. I can't have anything fancy there, like ax squared. If I do, that's a different kind of problem and I need substitution, which we'll do tomorrow. But as long as you just have an x or a u or whatever, if I have a constant in front of it, that's fine. The antiderivative will just require you to divide by that constant. Don't forget as well that, oh my God, I'm so sorry. I've been working for a long time. Don't forget that the antiderivative of AU is still going to have the AU in it, and you're going to divide by the A. So So here you have your 6 trig functions that we know the antiderivatives of. You've got your constant and your reverse power rule. And then we have our transcendental functions. So the antiderivative of e to the x is e to the x. But if there is something with that x, like a constant, I have to divide by that constant, just like reversing the chain rule. This here is our natural log. So this is basically the same as 1 over x dx, which would give me the natural log. But I can have a constant added or subtracted to that x. It didn't come up a whole lot last year, but every once in a while it did. And it's going to come up this year. Oh my God. Oh, just forget it. Not really, but please excuse me. I'm a mess. But the antiderivative of 1 over x plus a will still be the natural log of x plus a. You do need absolute value bars because we can't take the natural log of anything that's negative. So we have to put absolute value bars to make sure we don't mess that up. I wrote this may also look like this. So just because this one has the dx on the side, this one has the dx on the top, they're still the same thing. Okay, here is the inverse trig stuff. Put a hold on that. In fact, I don't even worry about looking at that. We're going to do that when we do substitution, but we are going to get into that this year, which we didn't have to last year. And then remember down here that if you have a multiplier, when I'm taking the antiderivative, that multiplier constant can just come out to the front. Okay, I think that's it. If this didn't record, I'm totally done. I'm just going to go eat a pint of ice cream and be done with it. So hopefully you watched this. And now I uploaded a video coming up, going over the notes. And then we have some Khan Academy. Like I said on the video that's coming second, don't skip these Khan Academies. Just because you watch me and you're watching the notes does not mean you have it. You've got to go practice. There are 4 of them today. And I know that seems like a lot, but they're only 4 problems each. So get it done. Just keep on working, one foot in front of the other. And I know you probably feel like I do, where you just want to go sit and read a book, or you guys want to go play Among Us, but don't give up. You got it. All right, I'm going to stop this now before I yawn another time. Even saying the word yawn makes me feel like I want to yawn. Okay.